Hi everyone, my name is Roman Janota, and I'm excited to share with you what I at CESNET have been working on. Imagine managing a massive network. So you start up your favorite network monitoring tool, and then you wait. You practically have time to make coffee while it loads. Before this tool can actually do anything, it first has to map out the network by parsing configuration files. Reading tens or hundreds of these files is incredibly slow. Eventually, it translates all that file data into a usable internal representation, a data structure that you can actually work with. But what if you need to run millions of users' queries at the same time? The whole process starts over, and you're stuck waiting again. As the networks grow bigger and bigger, this process gets more and more noticeable. So we ask ourselves, if all these programs are looking at the exact same network, why not just parse those files once and then share the result? So that is precisely what we did. Well, normally, once a program parses a data structure, it stores it privately somewhere in its memory. No other program can access it here. So we somehow needed to make it public. To put it simply, our solution moves this map from the program's private memory into a shared memory region where everyone has access to it. To explain what shared memory actually is, let's think of the following analogy. Imagine you have an important Google Doc with some very important data. Now, imagine you wish to share this doc with your colleague over email. Well, you can just simply write this doc, attach it to the email, and send it. The colleague then just downloads the document and opens it in like Microsoft Word. But what if you need to send this doc to multiple people? Not using shared memory would be like having to attach this document to every single email. Everyone would have to download it and open it, which is very ineffective. On the other hand, using shared memory would be like just sending a link to the doc to everyone, and now everyone has access to it with one single click. No downloading, no extra work needed. So in our case, the first program does the hard work and writes this document. Once it's finished, it creates a link to it and stores it in the shared memory. Now, when a different program starts up, it first checks the shared memory to see if there is a link to the doc already created by someone else. If there is, it can just grab it without any issues. If there isn't, that means that this program is actually the first one, and it needs to create the document by itself. There were some technical challenges we needed to overcome, though. Namely, what if any program decides it needs to make certain changes to the document? For example, changing the dog doc to a cat doc. Well, in our case, it could mean adding a new node to the network. Well, any program can do so without any issues, but it needs to let every other program know that there was a change. How we do this is that we simply generate a new link to the new change document and replace the existing one in the shared memory. So whenever any other program wishes to access the doc, it needs to check the shared memory every single time to see if there is a newer, different link. If it then sees that there is a newer one, the program just grabs the new link and can instantly go answer the user queries. Ultimately, this represents a completely different approach to starting up your programs. And I mean pretty much any programs with similar properties or bottlenecks. Looking at the benchmark results, our boot up times completely shatter the classical approach. The red bars show the boot up times of the old method, while the blue bars show the newer approach. And yes, the blue bars are missing from the graph. The difference is just that massive. Furthermore, in a larger data set, we achieved a huge speed-up ratio of around 400 times. This isn't just a minor optimization, it's a fundamental shift in how we handle massive data structures at scale. Thank you for listening, and feel free to contact me.